Alright, this is the example that we left off on, and we're going to come up with the sample space first of all we have a coin and this spinner. And what's happening is we're flipping the coin once and spinning the spinner once, and we're going to see the different outcomes that could possibly happen. And then we're going to figure out what the probability of a heads and a number greater than 2 would be. Usually when we're trying to figure out sample space, it's very helpful to write out a list of some sort, and a lot of times we use these tree diagram type things. So let's think about our coin first. We're either going to get a heads or we're going to get a tails. Okay? Now from there, no matter what we get, heads or tails, we're also spinning that spinner. And we're going to get 4 different outcomes by spinning the spinner. So we can get a 1, a 2, a 3, or a 4, right? So what could happen? Well, if we get a heads, we're either going to get a 1, a 2, a 3, or a 4 with that. So 1, 2, 3, 4. So we could get a heads, and we could get heads in a 1, heads in a 2, heads in a 3, heads in a 4. If we get a tails, same deal. We're either going to get a 1 with it, a 2 with it, a 3 with it, or a 4. So if I were to list out our outcomes in our sample space, so sample space, that would be, now I'm going to use the abbreviations here. Heads 1, heads 2, H1, H2, H3, H4. Having trouble with my H's today for some reason. Tails 1, tails 2, tails 3, tails 4. Alright. So that might not have been so obvious at first, maybe it was, because this is still a pretty small sample space, but making a list such as this definitely helps us out. So there's our sample space. It's for 1 coin toss and 1 spin. Alright, and it's important that it's only 1 spin and 1 toss, and we'll get into that later when we have more than 1 flip or more than 1 spin, that type of thing. We'll get into that in the future. So now our job is to figure out, now that we have the sample space, we want what is the probability of a heads and a number greater than 2. Greater than 2 and a heads, okay? So we're going to underline here everything that has a heads with it and everything that has a number greater than 2. Looks like, so we want greater than 2. It does not include 2. It has to be bigger than 2. So 3 is bigger than 2. Heads and bigger than 2. Heads and bigger than 2. So 2 of those are bigger than 2. So let's see how many outcomes do we have total. That's what we're going to need. So remember, our probability says that, or our probability formula says that we have the number of favorable outcomes over the number of total outcomes. So probability of heads and greater than 2 Alright, so this is something you'll see quite a bit. This means the probability of getting a heads and greater than 2. Just some notation there. And we want, how many outcomes do we have total? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 total outcomes. And the number of favorable outcomes would be 1, 2. So 2 ways. And this reduces to 1/4. So probability of heads greater and a number greater than 2 would be 1/4 there. Okay. Alright, this is our last one here. This one's a little more involved. We've got two spinners shown. We have spinner A with letters and spinner B has numbers. So we've got 6 numbers here, 5 letters here. And it wants us to find all possible outcomes when the two spinners are spun at the same time. I'm going to check and see. Oh, we don't get that. Alright. And we want to find the probability of spinning the letter M and the number 3. Alright. This one has a lot of outcomes. And what I'm going to do is show us the shortcut here. And that is right here, and we'll go back to it. So, in example 6, that's the one we're working on. Spinner A had 5 sectors, spinner B has 6 sectors. We could draw a tree diagram out, and that would take quite a while, but we would find out that we would get 30 outcomes. So we're going to use this fundamental counting principle is what they call it. It says if there are n ways for A to occur and n ways for B to occur, then there are n times n ways for A and B to occur together. So we should be getting 30 outcomes total. I could go ahead and draw out a tree diagram. So let's say we would spin a J, and then we would have 6 numbers that could go with J. We would have 6 numbers that could go with K. We could have 6 numbers that could go with L, 6 numbers that could go with M, 6 numbers that could go with N. So basically what we would have here is 6 times 5. So there should be 30 outcomes. And in this particular example, it does ask us to find all of those possible outcomes. So we would start off by saying J1, J2, J3, J4, J5, J6, K1, K2, K3, K4, K5, K6, L1, L2, L3, that type of thing. So we would have to find that for this one. And that would be quite a bit, but we could do that, it's not too bad. And then it says we want to find the probability of spinning the letter M and the number 3. Okay? So it would be M and 3, well that's only one outcome out of 30, so that would be 1/30th there. Alright, we will get into this more tomorrow. I believe that's all I have for today, and we'll see you tomorrow.